Okay, everyone, video 5 is going to have you working through a hypothesis test with 2 samples. So in this case, we have, where's my phone? The number of cell phones per 100 residents in countries in Europe is given in table 939 for the year 2010. The number of cell phones per 100 residents in countries of the Americas is given in table 9310, also from the year 2010. Is there enough evidence to show that the mean number of cell phones in countries of Europe is more than in countries of the Americas? Test at the 1% level. So again, always ask yourself, is this information that I've been given quantitative or qualitative? And again, if we kind of note here, we are literally looking at counts, so specific numbers, and not a yes-no question. So here we are dealing with quantitative data. So what I would like you to do is please pause the video and start to work through the hypothesis test, actually work through the entire hypothesis test. So your full phantoms process. When you are done, press play, and we will go through this solution. All right, I will meet back with you in a few minutes. Okay, everyone, so we are back, and we're going to go ahead and start going through the solution. So the first thing that we want to do is identify our random variables and our parameters. So in this case, we might say for group 1, let's say that it's Europe. We're going to say the mean number of cell phones per 100 European residents from 53 samples in 2010. Because again, if you go through each of those cells that you see in the data table, this is representing how many phones per 100 of those individuals we recorded. So in some instances, you might notice that like there's someone out there that has, so within a group, there's 130 cell phones amongst a group of 3 people. So if you think about it, there are some people that do have multiple cell phones, some for personal and some for business. So as we progress through, again, if we did a good job defining X bar 1, we can use that same structure just with some slight editing. We have our X bar 2 and our mu1 and mu2. So moving right along, we have our null hypothesis, alternative hypothesis, and our level of significance. So as before, we are going to believe that the mean number of cell phones per 100 residents in Europe is going to be the same as the mean number of cell phones per 100 individuals in the Americas. If we go back to our last question here, where they're saying, is there enough evidence to show that the mean number of cell phones in countries is more than the countries in the Americas? More would tell us that we should use a right tail test, or in other words, the greater than sign, assuming that your group 1 is representing Europe and group 2 is representing the Americas. So keep in mind that order is important, so please pay attention to that detail. And again, we are clearly told that our significance level this time is going to be 1%. So going right along, we're going to move into our 4 assumptions. We should have noted that we're going to assume that these pockets of 100 residents were randomly selected. We are going to believe that, yes, these 2 samples are going to be independent of each other. So we're basically saying here, just because I randomly selected from Europe, that didn't force me to, randomly select from the Americas in a very specific way. So we just kind of did our own thing when we were randomly sampling in Europe, and then again, we did our own thing when we were randomly sampling in the Americas. Is it normal, or is n greater than or equal to 30? We're going to say that since both samples are larger than 30, we've got 53 from Europe and 39 from the Americas, we should be okay. But I will go ahead after we get through our assumptions checklist. I'm going to go through our process of looking at the histograms, the box plots, and the normal probability plots for both groups. And then finally, we don't know the population standard deviation. So that might indicate to you which type of interval we're going to be working with. So now we're going to have to jump to the calculator in order to do our 2-sample t-test. But again, like I said, once we jump over there, I'm going to go through those checklists first just to make sure that our data is okay. And then we'll actually go ahead and do our 2 sample not test. Sorry. So after we jump into the calculator and do those checks for our sample, because like I said, right now, yes, they're bigger than 30, but we should make sure that we don't have any outliers or anything like that. If all of that goes well, we'll be able to name our test, and we'll call that a 2 sample t interval, because again, we don't know what the population standard deviations are here. So we're going to go ahead and jump to the calculator, make sure that you have that out. Okay, everyone, before we go into our 2 sample t-test, we need to check the normality for both of our groups. Because while we do have sample sizes that are bigger than 30, we need to make sure that they don't have outliers. And even if they do have outliers, we should go ahead and check the histogram and the normal probability plot as well. So remember to enter in your data. You're going to go into Stat, and then you would go into Edit. I've already gone ahead and added in my European data in list 1 and my Americas data in list 2. Next, we'll go into second and y equals. We're going to go into our stat plot 1. We want to make sure that it's turned on in order for us to see the images appear in the graph screen. And I would arrow down to types, and I actually already have histogram selected. But if I'm going to look at Europe first, I'm going to go ahead and do second and 1 in order to call L1 up. Then in order to see this, see the whole picture, let's go to Zoom and option 9. And we can see here, we're beginning to see some kind of a bell shape here. It's a little bit anemic over here, but again, we are seeing maybe with a little bit more data, we would have a little bit more of a bell shape here. It's on its way. We can go back and take a look at the box plot next to check for outliers. Again, we'll go down to type, and I'm going to select the 4th option where it looks like a box plot with those dots. So basically indicating that it will check for those outliers. Again, we're going to pull from list 1, and I want my mark to be a little bit bigger so that we can see it easily on the screen. So we'll do Zoom and 9. And here we do have 2 outliers. I will say that they are kind of balanced. That doesn't necessarily make it better, but we're going to kind of see how this plays out with the normal probability plot is basically what I'm trying to call out here. So if I go back to second and y equals, I'm going to go ahead and arrow down to type, and I'm going to go to the last option, which is my normal probability plot. Again, we still want it to pull from list 1. Our data axis should be X, and I'm going to use the larger marker. We'll do Zoom and 9. And here I'm seeing things are kind of coming in relatively straight. I'm also noticing like my one outlier seems pretty in line with the rest of them. And even this other one over here, it seems relatively balanced, I would say, at least in my opinion. And it doesn't seem like it's too far off from the other points. So there's slight deviation, but not a significant amount. So for now, what I'm going to do is I'm going to assume normality here. So let's go ahead and do the same checks for the Americas. We're just going to quickly kind of show those images instead of going through the whole process like I did with Europe. So here's the histogram for the Americas, and I would say that this looks pretty bell-shaped approximately. So let's go ahead and move over to the box plot. Our box plot also looks pretty decent, no outliers, so that's a win for us. Now the moment of truth, or perhaps the moment of truth, the normal probability plot. I would say the normal probability plot for the Americas looks okay. We definitely have a little bit of, I guess, deviation happening over here. It actually, I think, looks a little bit worse than the European group. But overall, we are seeing a nice straight line here. This is a little bit kind of wonky. But I think we have enough, given that we have no outliers. We are beginning to see a bell shape from our data, and we're seeing just slight deviation. I think we're okay to assume normality for the Americas as well. So now let's go ahead and move into our 2 sample t-test. So as before, we are going to go into Stat, over to Tests. We want option 4. And this time we have data, so we're going to go over to data and bold that. List 1 is going to be list 1 for Europe. List 2 is going to be list 2 for the Americas. Our frequencies will stay 1. And then in this case, we want a right tail test. So we are going to select the third option over here. It's still not pooled. We don't know if the population variances are equal to each other. So we're going to leave that as a no, and we're going to go ahead and calculate. And here we have our test statistic, or a t-value, of about 3 if we round it to the second decimal place, and a p-value of about 0.002 if we round to the third decimal place. So let's bring this over to our notes. Okay, so we've gone through the calculator. We've checked to prove that our samples, even though they did have outliers in them, or one of them had outliers in them, we could still assume approximate normality. That kind of just bolsters the assumptions that we've agreed to, as well as the fact that we still didn't know the population standard deviations for the groups. That justifies why we were able to do a 2-sample t-interval in this situation. So doing that, we found that our test statistic is going to be t is equal to about 3 if you round to the second decimal place, and our p-value is about 0.002 or 0.002 if you round to the third decimal place. Now that we have that information, we can go ahead and start making a conclusion. So we're going to compare our p-value to our level of significance, and whether you work with the decimal form or the percentage form, you're still going to make the same conclusion. 0.2% is clearly smaller than 1%, so this tells me that we get to reject the null this time. And from here, we would say something along the lines of, at the 1% significance level, we reject the null. We have sufficient evidence to support the mean number of cell phones per 100 residents in 2010 was greater in Europe than in the Americas. So now, again, we are going to create a confidence interval. So we're going to dive deeper, and we're going to find out, how many more cell phones did Europe have per 100 residents than the Americas? So keep in mind that you said Europe, group 1, is bigger than the Americas, group 2. So what type of signs do you expect to see for your bounds in your confidence interval? So if you're not sure, you're going to have to go to the next video anyway to find out. So I will see you over there.